Okay, video 2. Now that we've actually gone over what we're planning on doing, we're trying to make a doubly linked list, and hopefully this, I seem to be a bit jittery on the screen here. We're trying to make a doubly linked list, which means we need to have our original linked list. We're going to extend the class, so make a child class of the linked list class called a doubly linked list class. And since each doubly linked list node, each list node in the doubly linked list class has to point to the previous as well, we're going to need to extend that class as well. We're going to do this in a bunch of parts, but I want to do it sort of incrementally and hopefully do only a little bit at a time and see how we do. So the plan of attack right now, I'm going to make the doubly linked list class, see if I can make it compile without the linked list, doubly linked list node. Then I'm going to add stuff to the doubly linked list node. Okay, that's the plan. Okay, so how do we go about doing, and hopefully we'll see why certain things work. Okay, so how do we go about doing this? I'm going to have to have some end. I'm going to have to have a start. When I add an element to my linked list, I either add it to the front or the back. And when I add it to the front or the back, I'm going to change those pointers. And I have to update all the various pointers. So when I insert a node at the end, I have to update the end point and what it hooks to. And if I insert something at the front, I change the starting pointer and what these things hook up to. Then I need to worry about cases of like, what if the linked list is empty? What if it has one element? What if it has multiple elements? Am I putting it at the front or the back? Okay. So let's start slow and move on from there. We won't be doing the same sheer amount of debugging as the other version of the video has, sort of on purpose, so we don't flounder a little, or I don't flounder a little bit. But I really like the other video. It's just really long. So here we go. Before I get going, I had to make a couple little changes in advance because I know what's coming. One of the things I wanted to make as a change was I wanted to be able to get the start or get the end. These are protected methods. Remember we said we had differences between public, private, and protected. So here's our public functions right in here. Here's the protected functions in here. This is stuff that only other linked lists have. So if I make a doubly linked list, it can see these functions, but other things using it, like the main method, has no idea that these functions even exist. Only child classes and the original class have access to it. So the reason I might want to do this is because no one should know how the heck a linked list is built. It should be a magic box that stores stuff. If I didn't call it linked list, I call it Susan. Call it whatever. Super Magic Box 5000. If I make one of these things to store data, I don't want to know how it's built. I want to know it works. I want to know sort of rough description of what it does, but I really don't care how it works. When I drive my car, I don't care exactly how the engine's operating. I want it to operate. I don't want it to catch fire, but I don't want to know about the nitty-gritty details. That's a nitty-gritty detail. What kind of nodes are inside? I want to know it stores information. I can get that information. I don't have to run out of space. I don't want to know exactly how I don't want to know how the sausage is made. So get start and get end means I would return a linked list node, and I don't want to know what a linked list node is. What I want to do in the future is I want to have what's called an iterator, and that will allow me to go to the next, completely unaware how this thing is built. I could just say, get me the next one, get me the next one. Whether it's an array, a linked list, or whatever the case is, it works the same way. Just say, get me the next or get me the previous. I also want to be able, so in this case, with an iterator, I would just say, give me the start of whatever this data structure is. And the iterator would be an iterator pointing to the front of the structure. Don't care what it does or how it works. And then you say, hey, iterator, give me the data, and then you go to the next and next. We'll look at that later on. I also have something else because this is a private variable. Because my child class is going to need access to it, I'm going to need to be able to set the start pointer as well. So set this or get this. That's why I have that there. That's the only reason I have that there, because I really wanted this to be private. I don't want data to be given to everyone else, even to my children, right? They can go through a function. Thank you very much. Okay. So I implemented that. I also added a couple other things in here. I added these two new functions. Get the index, so get something at an index, and maybe I should say get value at index or something like that. It's not the number, but I want to say get me the fourth element in my array or in my linked list. So instead of using square parentheses and 4, I just say get the value at position 4. And it returns the data, not linked list node, the data. It's just a useful function. And maybe I want a function that tells me the size of my linked list. The only reason I have these, and they've re-implemented those things, you can look at the code, the code's online. The reason I implemented these is because I'm not going to touch them. I'm going to just completely ignore those, and it's still going to work, which is the really nice thing about this. Okay, so here's what I'm going to do. I'm going to break a brand new class. Okay, and so I'm going to make a new class. And the name of my class is going to be called DLinkedList, let's say. And my base class that I'm running it off of is LinkedList. That's it. So we didn't do this before. We're going to leave this alone the entire time. But a linked list, this is a child class of linked list. Everything that linked list has, you can get for free in WLinkedList. In fact, let's do that. It's going to make 2 new files, which we're promptly going to then ignore. It's going to, I have a header file, which pulls in the linkedlist.h, where everything's defined. And so this is a WLinkedList class, which is a child class of LinkedList. And I'm pulling in all this stuff. Okay, and here's LinkedList. There's WLinkedList.cpp. And it does nothing. There is nothing defined whatsoever. With me so far, hopefully. Let's compile it. All right, compiles. And you say, well, that's because it doesn't do anything. And I'd say, oh, ye of little faith. Let's do this. WLinkedList, boom, okay. And, oh, I'm going to need to make a WLinkedList. So include WLinkedList.h. All right. And everything works just the way I had it before. That's it. In fact, let's do something a little crazy. Let's go to linkedlist.cpp. I have this, where's my print? Linked list, get index, print. All right, so I want size, I'm going to change this. And then I'm going to have size, I'm going to call a function. And then I'm going to have put a quote, colon here. All right, and that should do it. All right, I'm going to test how big that size function works. Does it work? I sort of want to know. I haven't actually tested that. I just took it on blind faith. We're going to find out if I have a bug. Hey, all right, size 5. Oh, I forgot the closing. There we go. So size 5, 1, 2, 3, 4, 5. Size 3, 1, 2, 3, 1, 2, and then empty. Okay. And then do I have something that says the list is empty all the time? Oh, there it is. So if the list is empty, then I spit this out. Otherwise, I'm going to call the size function. Sounds good. Let's compile it again. Okay. I haven't done anything. I've made a brand new class, a child class, and I'm hoping that demonstrates, but maybe you don't believe me, but it demonstrates that a WLinkedList, the child class, is exactly like the parents. If I don't do anything at all, I get the parents functionality for free. Just looks like the parents. Everything I want to do that's different, I'm going to just change things around a little bit. So that's the plan. I'm going to have everything that the child has, although the parent class has, and then the child is going to do something slightly different. In our case, we wanted one new pointer, a pointer to the end. Okay, so I'm going to add those. Double linked list. And here we go. We were talking about private and protected. This is the big bug that one of the big bugs that I had in my original code that for the really long video, because I was just generating stuff really quickly. It happens to me all the time. I'm a messy coder. You shouldn't be, but you know, some of you are probably going to be like me. And if you don't say if it's public or private or whatever the case is, if you leave it off, it defaults to protected, which I don't know, it seems kind of weird that it's defaulting to protected, but that's what happens. And so no one knows about this function or no one knows about that variable as a result. I'm going to be very explicit. I want this. Okay, and I'm going to have a linked list node, and that's going to be p end, the end of my linked list. I want to have something that's going to let me set. I don't think I want to set that. Let's have a look. Oh, I'm going to have to change that part around a little tiny bit. We're going to look at that in a second, but I'm going to have some protected stuff. Protected. All right. And now what am I going to do? I'm going to make something for setting the end. Okay. Set end pointer like I had last time. And p new end. I can't type today. And do I already have a get end? I may already have a get end. Let's have a look at my linked list. My linked list class right here. Do I have a get end? I have a get end already. It's already protected. I already have something called get end. That works for me. All right. So I actually don't even need that function right anymore. Or actually, technically I do. I'm going to leave it in there for right now. I don't need get start, but we'll see this in action. Okay. What else do I need? I'm going to figure out what functions I need different behavior for. This will make a lot more sense once we hit polymorphism, but for the time being, what I'm going to say is if you redefine it, it means it's different. So it's a car. It's an electric car. Oh, it doesn't take gasoline. It's a special kind of car, the one that doesn't take gasoline. But the default takes gasoline. The electric car does not take gasoline. It takes electricity. It's a special kind of car. It's a race car. You know, it doesn't do this or doesn't do that. It's a four-door sedan or it's a truck or whatever the case is. The default generic concept of a car that you have in your head takes gasoline probably has four doors, probably maxes out 200 kilometers an hour or something like that. There's a bunch of things that it would have as default. And if I make a special case of it, I'll have to override or change what that original behavior was. That's what we're going to be doing now. So let me go over to my linklist.h. I'm going to see what all these things are. I'm just going to copy and paste them because whatever. I'm crazy that way. Sorry, I'm getting too playful for my own good here. All right. It's a double linked list. It's a double linked list. Insert at the front, insert at the back. I'm going to have to re-implement those things. Remove from the front, remove from the back. I'll have to re-implement those things. Re-implemented double linked list functions. Okay. I have these things I added to the original. I'm actually going to get rid of those things. I actually don't need to. They're going to be the exact same whatever way I do this. Is empty, don't need to redo it. And printing the thing, I don't need to redo it. In fact, these are the only four things I'm going to have to re-implement. And maybe not even that. Let's have a look at them. Okay. And then I have these two functions down here. Get the end, set the end pointer. Okay, so far I have not really done a whole lot of anything. I just need to implement these things here. And so my normal way of doing things, the super lazy Sprague way of doing things everywhere I had before. We're going to just fill this in. Now, this is also going to be wrong for the time being, but we're going to fix that up in a second. There we go. All right, I don't need the protected and all this other kind of stuff. So, super lazy Sprague way. All right, I did nothing so far. So far, so bad. First things first. So I'm going to intentionally have some errors for right now. First things first, I'm going to look at my constructor. Constructors for inheritance have a particular order. And so I'm going to play around with this. I'm actually going to look at what we did with LinkedList.cpp. Let's have a look. Okay, do I have anything inserted back, inserted front? I don't have, I have this destructor in here where I'm deleting all the individual elements. Let's do one thing here for all of these. See out. All right. And up here, a linked list. Linked list constructor calls. Okay. I just want to know the order in which these things are going to be called, because it actually will make a difference in our world, just to see how things play out. Okay. I will also need to use the standard template libraries. I think it's not using those. Yeah, there we go. I probably should actually move that to some other place. I'm going to move it around a little bit. Linked list node, I know is going to be like a base class for me, and linked list node.h. We're going to see something. The node is going to be in there. Yeah. So here's one thing you can do, and I like pointing it out in the past video, so I want to make sure I point it out here. It gets really out of hand when you have a whole bunch of files and you have a whole bunch of includes and you don't know what the order of things are going in. One approach you can take is to just find out what header file gets loaded in first. You need to load in absolute first. Find that header file, throw all, or yeah, let me see. The header file that you're probably going to need to load in all the external files with. Put in that header file in everyone's code, and in every one of those, in that header file, you include everything else. All the other includes you possibly could make. If it was already included, it gets left off. If it hasn't been already included, it gets put in. And so you get to control the include order. It's in one place. There's one source of truth, essentially. There's one place where all your header files are included all in one go. It's a technique to help with the insanity that is these include files, right? Oh, if this comes first before that, then this doesn't work. Yeah, you don't want to do that. So I could take something like my main. I can then remove, let me see here. Let's rip out all of this. And I'm going to include linklist node.h. I'm going to go to linklist node.h. I closed it by accident, sorry. All right, pragma once, meaning I only include it one time. So if every single thing includes ll node.h, they're all going to include all of these things, and they're only going to be included one time. LLInheritance.h, LinkedList.h, I might have to include other stuff. I have some asserts. I can use my standard namespace in here. Linklist node.h, it's already in there, that's fine. Let's see here. LLInheritance node.h, we could just say ll node.h, just include the base file for everything. This is to include LinkedList.h. You can include that. You don't worry about the order. You can just include them all in this one file. And so I'm going to need a couple other things. Oh, that's the header file. I don't need this thing. It's all in my header file. I don't need this thing. It's all in my header file. Essentially, I can make everything include LinkedList node.h blindly, and then afterwards, I can figure out what the heck LinkedList node.h requires. It's not going to work quite yet. Let's make one more change. Okay, double LinkedList. I'm going to need to include no. Oh, I am in LL node.h. That double LinkedList node. Oh yeah, I got everything. That's great. At least I think I do right now. So here's my linked list node. This is the file that I was working on. So now that I have everything, I'm going to just save them all. Everything's going to go to, this one right here. It's going to include my IO stream. It's going to include assert.h. It's going to include this header file, the current header file, and then afterwards, it's going to fill in all the other stuff. So as long as it does it in that order, I should be fine. And my struct LL data. Perfect. Okay. Let's go to my linklist.cpp. It does nothing right now. But what's it barfing at me for here? I have a variable that's uninitialized. So let's initialize it. P end is equal to null, right? At the start, I would want p end to be equal to null. I have one other thing weird thing going on about this. Let's have a look at linklist linklist.h. It takes in nothing. That's fine. Linklist node.h takes in nothing. Okay, we're fine. I'm going to leave it alone for right now. But here's, well, actually I won't leave it alone. Exact same thing if I do this. Don't have that in space. This says when you call this constructor, you call this version of the constructor for linked list before you move on. That's one thing you can do. I'm going to leave it off for right now. Also, considering I may have a bug or something in there. Let me also look at this variable. DLinkedList pend is uninitialized. I did it. Oh. Let me have a look at this. LLInheritance.h, LLInheritance.h. Pend is uninitialized, but it is actually initialized. I initialized it right there, so why is it yelling at me? Doubly linked list. Let's try this, just on the off chance. That's where this pointer comes in handy. Pend. So it's definitely going to be that thing. It's definitely initialized. I don't know why it would be still problematic. Well, it's only a warning right now, but I just don't know why it's doing that right now. Let's move on for a tiny bit for right now. I have a destructor. I'm automatically going to call the child of the parent destructor as well. We will see that in action very soon. Inserting at the front. What does that mean? It means that the p start value is going to change. Okay. Do I need to do anything with that? I have one exception. I have one thing I may have to worry about. If I insert at the front and there's nothing in my list already, then the end is also at the front. So I had nothing. So I have an empty linked list and I insert one element. The last element is also the first element. And so what I want to say is if p end is equal to null, then I want to say p end, and so we have is equal to by the way, and one more thing. I can call my parents function. I can say, I'm going to call the insert at front on the generic linked list and then do a little bit of extra bookkeeping at the end. So if the end was not didn't exist before, now it does. Okay, how about inserting at the back? I could, what I might need to do is get my, so if I'm inserting at the back, what do I know? I know the thing I'm going to be adding is going to be, let's see what my linked list does. Inserting at the front, if I insert at the front of my linked list, what do? I make a brand new linked list node. I make a node, I set the next to be equal to start, I set the start. I might have to do that sort of craziness. I could have also, yeah, let's do that, this kind of craziness. So if I'm inserting at the back, what do? I make a brand new linked list node. If the start does not exist, and I don't have access to that start, notice it says p start and it's underlined. This is saying I don't have access to it. The variable's there. I'm saying this, I don't have access to it. It's private. So I need to do get start. I can do that. If get start is not equal to null, it's the same as just saying if get start, by the way, because if it's not null, it's not equal to 0, therefore it's true. Okay, if get start is not equal to null, then I'm going to, well, then what do I need to do? I need to, this is inserting at the, I was doing it, insert at front. Insert at back is this one here. I need to know if I have the endpoint actually. So if I have an end, I'm going to have to pause for a second.